Okay, good morning everyone. I welcome you to this wonderful session. And of course, today we shall be doing science paper 2. Now, let me make this emphasis. I will make sure that I simplify your mock concept, your methods, and also other topics that are really so important like the periodic table. Most of you really struggle a lot, especially with mock concept. And mock concept doesn't miss. But I'm going to show you the tricks that you'll be using whenever you want to solve a question under mock concept. And also concepts on periodic table, you will need to understand them. Not only the periodic table, also methods and things like organic chemistry, which I will be able to highlight to you. Now, I will be posting videos almost every day. So make sure that you subscribe to this YouTube channel. Subscribe to this YouTube channel right now. Follow this YouTube channel and you access all the lessons that I post on this particular channel. And of course, if you want personal tuitions, make sure you inbox on this WhatsApp number, which I'll show on the screen, which is +26 0777 66 40 46. And then I'll be able to respond to you. And then you can ask me questions concerning anything that you want. Okay, now let me proceed with answering this particular paper. Travel with me. Let's get started. We'll start with the MCQs or the multiple choice questions. You are given particularly 20 multiple choice questions, which I'll be able to explain each one of them, how the answer will be coming about. The first question is saying, Elena accidentally sucks into the mouth a solution of sodium hydroxide during titration. Choose the appropriate action Elena should take. Now, sodium hydroxide is a basic medium. Okay, sodium hydroxide is a basic medium. It has no acidic content in it. It's a basic medium. That implies that even if it gets into your mouth or into your stomach, it will have no effect on you. And that is the reason as to why your answer is going to be D. Spit out the solution and thoroughly rinse the mouth with the water. Water is basic. Sodium hydroxide is also basic, no effect. So your best answer is going to be D. Next. Which states of matter exists at the boiling point of a substance? So a substance is boiling. When a substance is boiling, it is a liquid. At the same time, it is in its gaseous state. Then once it boils, it becomes a gas. So boiling is a state of liquid as well as gas. Okay? And that is why your answer is going to be C. Okay? Question 3. The diagram shows the changes of states among the 3 states of matter. Okay? As you are able to see on this particular diagram that they've showed you different states of matter. Then the question is saying, why are these changes called physical changes rather than chemical changes? So a physical change is something that you cannot change. You cannot alterate with it. Okay? It can't be changed in any way. It remains the same way it is. A chemical change is something that you can easily change. Okay? Or it is something that can produce new substances. That's what I mean. Okay? When I say change. In other words, 2 molecules can react to produce a new product. But for physical changes, you are reacting 2 molecules that cannot significantly produce any other molecule. Okay? So, no changes can actually be made with physical, but changes can actually be made with the chemical. Okay? So, the best answer is because they produce no new substances. They can't be changed. So, the best answer is D. Which of the following is the best method used to separate sugar crystals from sugar solution during the production of sugar? Now, you have sugar crystals. At the same time, you have sugar solution. Whenever you hear crystallization, you are separating two solids. One is a crystal, one is dissolved in a solution. You are going to use crystallization. Next, Elena accidentally mixed iodine crystals with magnesium chloride. Which method would be suitable to separate this mixture? Now, this is iodine crystals with magnesium. Magnesium chloride is a salt. Okay? So you have got crystals as well as a salt. So the best way is simply to heat, okay? To heat the substance. One is going to vaporize, the other one is going to remain and eventually form crystals. And that is why you are going to go with D, which is simply sublimation. Which of the following is the approximate mass atomic unit for electrons? It is simply 1 over 1840. Okay? 1 over 1840. Okay? So make sure you take note of that. I'm sure even when you check on the periodic table, just underneath there on the corner, you would be able to see 1 over 1840. So best answer is actually B. Okay, you use the 1 over 1840 to also define isotopes. The following diagram shows the structure of an atom for element W. So this is element W. Choose the chemical formula of the compound formed when W reacts with the oxygen. Okay, when W reacts with the oxygen. So, oxygen, when you check properly, you will notice that this W molecule, it has 1 electron in its outermost shell, meaning it has a valence of 1. So, W has a valence of 1, right? Then oxygen has a valence of 2 minus. This we already know. So, this one will come this side, this one will come this side. W is going to be W2, then oxygen. This is how your formed molecule is going to look like. And that makes our answer to become C. Okay, so this one was actually very simple. You just needed to show this particular, how a molecule is actually formed. Okay. Hydrochloric acid is used to clean some metals. The acid reacts with oxide layer on the surface of the metal. Which of the following are the products? So we've got an acid which is reacting with an oxide layer, okay? Which is reacting with an oxide layer. An oxide layer of a metal. So when acids react with a metal, what do they produce? There are 2 things they produce. The first one is called the salt. The second one is called water. When an acid reacts with a metal, 2 things are produced. One should be a salt, the other one should be water. Okay, so number 8 is simply D. Please take note. Acid plus metal is equal to salt plus water. Let's go to question 9. Question 9 is simply stating the results of 3 tests carried out on a solution of compound M are shown in the table. Then they say this is aqua sodium hydroxide. When added, it produces a white PPT formed soluble in excess. Then aqueous ammonia added, it produced a white precipitate which was formed soluble in excess. Then when aqueous hydrochloric acid was added, effervescence of a gas that turns lime water milky observed. Now, All this is not important. This, you won't be able to get the answer from this description. The answer is here. Effervescence of a gas that turns what? Lime water milky was observed. So it's a carbonate. A carbonate is the one that turns lime water milky. So this one should come out. This one should come out. Okay. Now they're saying hydrochloric aqueous hydrochloric acid was added. Effervescence of a gas that turns lime water milky was observed. Okay. And then they say aqueous ammonia was added. A white precipitate was formed and it was soluble in excess. So aluminium in excess is not soluble. The one which is soluble is actually zinc carbonate. Okay. Zinc carbonate. Aluminium is usually not soluble because it is very unreactive. And what makes it unreactive is because it easily combats with oxygen when left in air, in free air. It combats with oxygen, making it very unlikely to react with anything. So it is less likely to be soluble. But for zinc, zinc is very much soluble. Okay? Very much soluble, especially in substances like ammonia. Okay? We have this question. 2.4 grams of magnesium ribonose reacted with 100 centimeters cubed of 2 molar dilute sulfuric acid. What is the volume of the gas which was produced at room temperature and pressure? So the first thing that you need to know is they've said 2.4 grams of magnesium ribonose reacted with sulfuric acid. So the first thing you need to do is simply to be able to generate an equation. So if we wanted to generate an equation, we're reacting magnesium. Let's try to do this. So magnesium is reacting with sulfuric acid. What is being produced is going to be magnesium sulfate. Okay. Magnesium sulfate. We all know how to write magnesium sulfate. The 2 on magnesium and the 2 on the sulfate will cancel each other. And then what you're going to produce is simply hydrogen gas. Okay. And it is actually this gas that is escaping. The hydrogen gas is the one that we are looking for. It is actually the gas that is escaping. Now, what exactly do we have? We have been told that 2.4 grams of magnesium ribonose reacted with 100 cubic centimeters of 2 molar dilute sulfuric acid. So we can find the number of moles of sulfuric acid. Okay, we need to find the number of moles of sulfuric acid. But before we do that, remember that this is not in decimeter, so we need to change it. So we can say 100 over 1000. Let's see, 100 over 1000. You change it into cubic decimeters. You're going to have 0.1 decimeters. Okay, 0.1 cubic decimeters. Now, after you have your 0.1 cubic decimeters, let's try to see if at all we can find the number of moles. So, number of moles for this particular acid. Okay, so you can say the number of moles is going to equal to, okay, I might confuse you if I go directly. So concentration, or the molar concentration, is equal to the number of moles over the volume. You cross multiply, the number of moles is equal to, so what we have is a 2 there, 2 multiplied by 0.1, number of moles is equal to, so 0.1 multiplied by 2, we're getting a 0.2. Now we have found the number of moles of this particular acid, right? Which happens to be your 0.2. Now, after having found 0.2, we can now try to find the moles of, we can use the mole to mole ratio to simply find the volume of this particular guy here. Okay, so you are going to get your magnesium, try to compare it with so you try to compare it with your gas which was produced, because that's the one it is relating to. So you compare it with your gas. Now, we have found the number of moles of this particular acid. Which other number of moles should we find that can help us? Let's try to find for magnesium. Also, it's very important. That's why we're given this mass. Now, we know that magnesium, the mixture of magnesium on the periodic table. Okay, let's check it out. The mixture of magnesium on the periodic table is simply 24. So 24 is the mixture of magnesium. Then we say number of moles is equal to the mass over the mixture. So number of moles is equal to, what is the mass? It is 2.4 over 24. So the number of moles you're going to have is 0.1. So you're going to get your 0.1 moles of magnesium. You put them there. Okay, so these are the ones which are going to help us. Okay, let's forget about this first. Then 0.1, we are going to compare it because it's a mole to mole ratio. So let's check. First of all, let's check mole to mole ratio. So because it's a mole to mole ratio of 1 to 1, because we have 1 mole, there's only 1 mole here of magnesium. Let's check also 1 mole here of hydrogen. So even here there's 1 mole of hydrogen. That implies the 0.1 mole of magnesium is the same one for hydrogen here. Or if you want, you can calculate. You just put x here, then you cross multiply. So x is going to equal to 0.1. Have you seen? So this 0.1 is the number of moles of this acid. Okay, sorry, this gas here, hydrogen. Now remember, they are saying at room temperature and pressure. So at room temperature and pressure, 1 mole of any gas is equal to 24 cubic decimeter. Okay. Then how about 0.1 of hydrogen? How is it going to be? We put x and we cross multiply. So 0.1 multiplied by 24, we are getting 2.4 cubic decimeter. Okay, so where is our answer? The answer is going to be B. So basically here, all you have to do is create a balanced chemical equation. When you create that balanced chemical equation, compare using mole to mole ratio. Okay, get your magnesium, compare it with your hydrogen. You have 1 mole of magnesium. There you have 1 mole of hydrogen. Find the number of moles of magnesium. Put an x here, cross multiply. Find the x, which are going to be the number of moles of hydrogen. Then from there, because it's at RTP, make sure you multiply by 24. Whatever you get is your answer. Okay. We come to the next question. Calcium carbonate thermally decomposes to form calcium oxide and carbon dioxide, according to the equation given. Then they say 8.0 grams of calcium carbonate was strongly heated in a crucible and 3.4 grams of calcium oxide remained in the crucible. What was the percentage yield? Now, percentage yield is actually very simple to calculate. It's just the actual yield over theoretical yield. So you can say percentage yield is equal to actual over theoretical multiplied by 100. Now, let me show you how simple it is. Get your the same thing that I did on top. Get your balanced equation. So this is our balanced equation. Now, they are saying, what was the percentage yield of calcium oxide? So they want us to calculate the percentage yield of this guy. So get what was decomposing. So it was calcium carbonate. Compare it with what is being produced, which is calcium oxide, right? Find the mixture of calcium carbonate. We know it is 100. Find the mixture of calcium oxide. So the mixture of calcium oxide, how do you find it? So it's going to be 1 multiplied by what is calcium? Calcium is 40. Then oxygen, it will be 1 multiplied by 16. So from there, we say 40 plus 16, 56 grams per mole. 56. So this is going to be 56. Of course, this is going to be gram per mole. Even here, we're going to have 56 gram per mole. Just find the mixture. Okay, find the mixture of calcium carbonate and the mixture of calcium oxide. Then from there, what do you do? Simple. Just get your 8 grams, which was given for calcium carbonate, put it here. Then this side, put X. The same thing that I did. You see how simple it is? So from there, you cross multiply. Then you're going to have 100 this side. So 100X is equal to, then we're going to say 56 multiplied by 8. Then you'll find 448. Then you divide by 100, even this side by 100. You'll see what will happen. So if you divide by 100, you're going to get something like 4.8. 4.48, okay, grams. Okay, 4.48 grams. Now, this 4.8 that you have calculated is what we are calling as your theoretical, because you theoretically calculated it. Now we can solve. So iyo bachikupereye mu question iyo ubika pamundu. Okay? Iyo ubika pamundu. So you get your 3.4 over, then you are going to divide it by that value which you calculated, like this. Then you multiply it by 100. That's how simple it is. So just get your 3.4 divided by 4.48, then multiply by 100. You're getting 75.89, which you can round off to 76%. Okay, and that's how they found the answer to be A. Hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen and water. Apart from increasing the temperature, suggest the best way the reaction can be speeded up. Okay, so apart from increasing the temperature, the best way to increase a reaction is simply by using a suitable catalyst. Just use a catalyst, you speed up the rate of reaction. Of course, the answer is going to be D. The diagram shows the electronic structure of an ion of element L. To which group and period of the periodic table does element L belong to? Now, guys, I want you to look at this. I want you to follow me well. Now, you have seen what is inside here. These are electrons in their shells. Now, here they're telling you that this is 3+, which tells you that this element had 3 extra electrons in its outermost shell. In other words, at first, before they did anything, okay, it was like this. I want you to see. Okay, this is how it was at first. They just wanted to confuse you. Okay? Then the last one contained 3 electrons. Okay? Now these 3 electrons, because it's supposed to lose the 3 electrons to become balanced, that is why they are saying it's 3+, because it is losing. Now, I want you to look at this. Because it has got a valence of 3+, the valence is what determines the group. So it is going to be in group 3. Now, this is why I wanted to see the concept. Because it has got 3 shells, the first shell, the second shell, and the third shell which you could not see. It is going to be in period 3. Simple. So group 3, period 3 is B. That's how you found B. Okay, if you found that question. Let's enjoy these questions, guys. Which is the electronic configuration of a noble gas used to provide an inert atmosphere in welding? Okay, electronic configuration of an inert gas which is used in welding. Okay, so of course, welding, we know that we use argon. So let's check, where is argon? Argon is found in group 8 of the periodic table. Okay, so of course, argon is written like this. Let me show you. Argon is written like this. On top, it has 40. Down here, it has 18. You are using this to write your electronic configuration. So because it has 18, the first shell is going to hold 2. The second shell is going to hold 8, which make it 10. The second shell can hold 8, which make it 18. So this is 8 plus 8 is 16 plus 2, it is 18. And this is the 18 we're getting. So this is going to be the electronic configuration. Okay. Metal Y was added to iron sulfate solution, and the solution changed from green to colorless. What is the identity of metal Y? So I want you to really get something. You have a metal Y which was added to iron 2 sulfate solution, and the solution changed from green to colorless. So this is under metals. You will need to know the properties of all metals. Which one turns pink, which one turns green, which one turns what, whichever color, which one turns colorless, especially more of aluminium. But when you say green, green, pink, for pink, copper, of course, green, zinc, magnesium, can. Okay, so the answer is going to be A, magnesium. Copper, don't line it up with this particular property. Okay, so magnesium, zinc, those 2 elements, they usually present with that particular, though zinc sometimes brown, copper pink, yeah, like that. Okay, so magnesium, of course, is your answer. The diagram shows the main stages in the manufacture of an ammonia-based fertilizer. We've got nitrogen, of course, this is Haber process, is nitrogen, this is hydrogen. What is happening in the process labeled Y? Okay, so of course the answer is simply D, because you have untreated hydrogen and nitrogen which are just being recycled. Okay, here 17. Methane is reacted with steam in the presence of nickel as a catalyst to produce gas and carbon dioxide. Okay, then they say, what is the suitable method of collection for gas T and the reason? Okay, so of course it's going to be upward delivery, and then the gas should be less dense than air. Okay, upward delivery, gas should be less dense than air. Which one is that? Okay, B. Pollutant gases are released by the bacterial decay of vegetable matter. Which gas is mainly sourced from decay of vegetable matter? Can you try out this one? Okay, perfect. You got it correct. It's actually methane, which also happens to be natural gas. Of course, methane. Butane can undergo an addition reaction with steam to form compound R. What is the name of compound R? So you are reacting an alkene. You are reacting an alkene with water. Precisely, you should know that you are going to produce an alcohol. So this one is butane plus water. You're going to produce butanol, which is an alcohol. Polymers are made using monomers. The following are structures of some monomers. We've got W, we've got X, we've got Y, we've got Z. Identify the correct set of monomers that form a polyamide linkage. So, a polyamide linkage contains an amide, functional group, so we're going to have an amide functional group and a carboxylic acid functional group. So, an amide functional group is going to look like this. A carboxylic acid functional group will look like this. Or, sorry, it's supposed to be OH here. Let me put the O this side. Like this. So, this one should be there. And also, this is the carboxylic acid. So, there's no carboxylic acid, okay. Here at least there's a double bond. Here there was no double bond. Okay, so this one is going to be, let me see. This one suits perfect. So it's going to be Y and Z. Okay. That's how I would solve it. Okay, that's how I would find my answer accordingly to me. But actually, that's the correct answer. Let's try out section B. Now, this section is actually very interesting because most of the topics that you underrate actually come. The first question was actually stating there are various challenges caused by chemical industrial activities. State one challenge caused by chemical industrial activities on the land. So chemical industrial activities, you're throwing waste, you're throwing rubbish on the land. What happens? Land pollution. Okay? Land pollution. Land pollution is what you are risking that environment to contain. Then it says, suggest a method you would use to minimize the challenge you have stated. How exactly would you minimize land pollution? It's simply to collect garbage and throw it to hazardous waste facilities that have been permitted by government. So the best way is simply to treat, of course by the council, to treat and dispose. Okay, to treat and dispose wastes in permitted hazardous waste facilities. Okay, that's why you throw them. Okay, in permitted hazardous waste facilities, areas that have been permitted by the council facility. The models labeled A, B, and C are for the three states of matter. The melting and boiling points of substance E are also shown in the table. Now, this substance has a melting point of negative 114 and then a boiling point of 79. Now, this is what I want you to do. So, this guy has a melting point of negative 114. This same guy has a boiling point of 79 degrees. Now, I want you to see, how simple this question is. The first question is saying, which model represents the state of substance E at a temperature of pure melting ice? Now, pure melting ice melts at 0 degrees, right? Pure melting ice melts at 0 degrees. Now, we have been taught that this compound here that we have, it has a melting point of negative 114. So anything that is above 114, and as long as it is less than 79, because this is the boiling point. So anything that is going to be above 114, to this particular substance E, it should start melting. It should be in its liquid state. So because 0 is greater than negative 114, or in other words, 0 is falling above 114, and also it is falling above 114, and also it is less than what? It is also less than 79. So because it is falling in between negative 114 and 79, meaning it is a liquid. And that is why, okay, it is going to be B. So which model represents the state of substance E at a temperature of pure melting ice? Pure melting ice is 0, and according to substance E, 0 is in its liquid state, which is B. Which model represents the state of substance E at a temperature of pure boiling water at sea level? Now, the boiling point of pure water at sea level, what did I say? I said it is 100 degrees. Now, because 100 is above 79, that implies that this guy here is in its gaseous state, and gaseous state is simply C. So that's how you're going to put your C here. Then they say, which model represents the state of substance E at room temperature and pressure? Room temperature and pressure, you have 25 degrees Celsius. 25 degrees is room temperature and pressure. Now, 25 degrees is above negative 114, and it is less than 79, meaning it is also falling in between. And in between, what did we say? Liquid, which is B. It's melting. Okay, that's how you answer that particular question. We go to the next question, which is going to be B2. The electronic configuration of element J is, so we've been given that electronic configuration. J is not the actual chemical symbol of an element on the periodic table. Then they say, in which group? Look at this. This is J, right? And this is its electronic configuration. I want you to look at this properly. So whenever you are dealing with electronic configuration, the last number that they put is always very important, because the last number is what will tell you the group. I said the group, not the period. It will give you the group. Okay? The last number will tell you the group. Now, these numbers 1, 2, 3, 4, 5 are telling you about the period. So when you count them, you find the period. The last number in the electronic configuration is telling you the group. So now, in which group of the periodic table is element J found? Okay? In which group of the periodic table is element J found? So what did I say? The last number is telling you the group. Very good. It is in group 1. So you're going to say this is found in group 1. Explanation: because it only has one electron in its outermost shell. It only has one valency electron in its outermost shell. Very good. You go to the second one. It says, period of the periodic table is element J found. So they want us to find in which period of the periodic table is this element found. Let's calculate the period. So this is going to be period 1, period 2, period 3. This is very simple. Period 1, period 2, period 3, period 4, period 5. In other words, you count, these are shells. So shell 1, shell 2, shell 3, shell 4, shell 5. So because we have got 5 shells, the number of shells tells you the period. So this is in period 5. Don't forget this in your exam, period 5. What is the explanation? It's because it has 5 shells occupying electrons. Okay? Being occupied by electrons. So you can say because it has 5 shells being occupied by electrons. Simple. Name an element in group 5 which is in the same period as element J. Okay? Name an element in group 5 which is in the same period as the element J. Okay? So they want you to find an element. So you go on the periodic table. You go on the periodic table. You check where group 5 is. So this is how you move. If this is the periodic table, right? If this is your periodic table, whenever you're going down, okay, whenever you're going, let's say this is how your periodic table is. If you're moving in this direction, these are your periods. So you've got this first one is period 1. Sorry, this one is group 1, group 2, group 3, and group 4. Okay? That's how it is. Then whenever you're going downwards, that is your period. Sorry, unfortunately, I think the periodic table is at the far end, so it will be very unlikely for me to scroll. But if you get your periodic table, just do what I have done. So if you check properly, you want to name an element, of course, which is in the same period as element J. So make sure you go find the period. So go downward from hydrogen 1, where lithium is 2, where sodium is 3, where potassium is 4, going downward. Then we're on 5. 5, what do we have? We've got rubidium. Okay, rubidium, just underneath potassium. So going downward, those are periods. Now they're saying in group 5, let's see, group 5. So group 5, 1, 2, 3, 4, 5. Okay, let's just pick rubidium because it's an element also which is found in the same period as element J. So rubidium, I think we can get rubidium. It's okay. Rubidium. Okay, so this one was actually a 1 mark, quite simple because you just needed to pick it from the periodic table. B3 is saying an anhydrous ion 3 chloride salt can be prepared by reacting hot iron metal and chlorine gas in a combustion tube. What does the term anhydrous mean? Okay, so anhydrous is simply a substance that contains no water of crystallization. Okay, so you can say a substance that contains no water of crystallization. Describe the method by which iron chloride is prepared. Of course, the method is called direct combination. Method is called direct combination. Write a balanced chemical equation for the reaction between iron, metal, and chlorine gas. This is where I wanted to really focus much. They are saying, write a balanced chemical equation for the reaction between iron metal and the chlorine gas. Now, this is what is reacting, but I want you to pay extra attention to what I'm going to do. To form iron 3 chloride. How is iron 3 chloride formed? Because we know that iron 3 looks like this. Then a chloride looks like this. So iron 3 chloride is going to look like this if you form it. Okay, sorry, this is supposed to be a 2, of course. Okay. So, sorry, chloride only contains, let me see, it's in group 7. Okay, 7 minus 8, negative 1. Okay, so it only contains a negative charge. Of course, when they exchange, you're going to have iron there, chloride is going to contain a 3 here. This is what you call iron 3 chloride. So this is what was being produced. So what do you do? Write an equation. Your equation is going to look like this. You're going to have iron. Okay, iron, which is a solid. Make sure you put also the signs, solid, or the states, plus chloride. So a chloride is simply a gas. It's produced in iron 3 chloride. So iron 3 chloride, we've already seen how it's written. Now we need to balance this particular chemical equation. So let's check how we are going to actually balance it. Okay, sorry, so this is supposed to be a chloride. Chloride has two diatomic, it's a diatomic molecule. Chloride is a diatomic molecule, meaning it has two chloride molecules, two chloride atoms. Okay, now let me see properly. Iron is reacting with chloride molecule, producing iron 3 chloride. Wow, how do you balance it? So first of all, we can balance the chloride. Let me see, how many chlorides do we have? We have got 3 chlorides this side. This side we have 2. So how about if we put a 3 here? It implies that we are going to have 6 chlorides. This side we are going to have 3 chlorides. So I can put a 2 here. So I'm going to have 6 chlorides this side, 6 chlorides this side. Chloride is balanced. How about iron? It's not. I've got 2 iron this side. I can put a 2 here. And that's my balanced equation. So let me see what I'm going to have. So this is going to be 2 iron in its solid state plus 3 chloride. Chloride is a diatomic molecule. In other words, it has 2 molecules, 2 atoms. This is going to be your iron. And then this is going to be chloride 3. This one is going to be a salt. So in aqueous state. Okay, that is going to be a balanced equation. They will give you a full mark for that. Describe what would be observed if sodium hydroxide solution was added drop by drop to a solution of iron chloride in a test tube. Okay. Of course, you would be able to see this reddish brown precipitate of iron 3 being formed. Okay. You'd be able to see a reddish brown precipitate of iron 3 being formed. Okay. A reddish brown iron precipitate. Nishmapusha. You even get all the marks. Okay. Nishmapusha. You are entitled to get all the marks after doing that. We go to the next question. Okay. We go to the next question. Let's see what's there. All right. This is so amazing. So, okay, let me check. Do we have? Okay, we have calculated this. We now come to more concept. They're saying 4.0 grams of impure iron oxide reacted with 600 centimeters cubed of 0.1 mole per cubic decimeter sulfuric acid. Then they say construct the balanced chemical equation for the reaction. Okay, we construct a balanced equation for the reaction. So this is impure iron 3 oxide. So let's check, how does iron 3 oxide look like? The same thing. We're going to have iron 3, then oxygen, like this. Then this guy is going to come this side. This guy is also going to come this side. So expect iron 3 to look like this. Now they're saying it is reacting sulfuric acid. So iron 3. So okay, let's do this. Iron 3 oxide reacting with sulfuric acid. What is going to be formed? So of course you're going to form iron sulfate. How is iron sulfate going to look like? Okay, iron sulfate is going to look like this. So this is going to be your iron 3, then a sulfate. So this can come this side, this side. Then you're going to have something which is going to look like this. Your iron is going to have a 2 here, which is coming from the top. You open the bracket, then the 3 from iron will come here. So this is what is going to be produced. Right? This is iron 3 sulfate. Plus what? Iron 3 sulfate is solid. You're reacting with an acid. What you're going to produce is water at the end. Okay? Water. Now let's check if it is balanced. How many ions do we have? This side we have 2 ions. This side iron is balanced, oxygen. This side we have 12 oxygen. On my left, 12 oxygen. This side, how many oxygen do we have? This side we have about 13 oxygen. So because we have 13 oxygen, we can balance them up. So if we put a 3 here, if we put a 3 here, how many oxygen do we have? So this is going to be 12 plus 3, 15. 15. And then if we put a 3 this side, how many are we going to have? So 3 multiplied by 4, 12. 12 plus 3 is 15. So oxygen is balanced. What else should we balance? Okay, now this is a balanced equation because every other thing is balanced. Okay. All right, this is beautiful. It's balanced. So let's just put the states. So this one is solid. This one is aqueous. This one is aqueous. This one is liquid. So this is what is going to be formed. F2 oxygen 3 solid plus 3H2. Okay, this is a sulfate, of course. It's in aqueous state. And then this is producing iron 2 sulfate, which is going to be in aqueous, plus 3H2O, which is a liquid. That's how you calculate your balanced chemical equation. Now they're saying calculate the mass of the pure oxide that has reacted with the acid. So they want us to calculate the mass of the pure oxide. But let me see what we have. Well, they are saying 4.0 grams of impure iron oxide reacted with 600 cubic centimeters of this of sulfuric acid. So from here, the first thing that we are going to do, of course, we can try to use the mole to mole ratio. Okay, we can try to use our mole to mole ratio. We see what we are going to have. The same concept that I actually taught is what we shall basically use. Now remember that we have this volume, we have this number of, okay, this is the volume, this is the concentration. So let's calculate the number of moles of sulfuric acid. So the number of moles of sulfuric acid is going to equal to, let me see, do we have the concentration? We do have the concentration. So that I don't confuse you, let me just write the formula. Concentration is equal to number of moles over the volume. The concentration that we're given is 0.1. The number of moles, we don't have them. That's what we're looking for. Now, the volume is in cubic centimeters. So convert it into these units, which are decimeters. So you just say 600 divided by 1000. 0.6. Then you cross multiply. You're going to get n is equal to 0.1 multiplied by 0.6. We're going to have 0.06 moles of sulfuric acid. Now we can use the 1-to-1 ratio. So we have iron 3. Okay, we are going to compare it with what we know we already have. From there, how is the mole to mole ratio? Here we only have 1 mole. Here we have 3 moles from the balanced chemical equation. Then here we have X, that's what we are looking for. Here we already have the number of moles. We can cross multiply. You're going to have 3x is equal to 0.06 over 3 over 3 even this side. So 0.06 divided by 3. You're going to get something like 0.02 moles of what? Of iron 2. Of iron 3. Twasangama moles ya iron 3. Now, after we find the moles of iron 3, they are saying we find the mass, right? So we need to find the mixture. Okay? We can try to find the mixture of iron 3. So how do you find the mixture of iron 3? This is going to be our iron 3. So iron, let me check iron on the periodic table. So iron is 56. So 2 multiplied by 56. 2 multiplied by 56 is 112. Then of course we can calculate for oxygen. It's going to be 3 multiplied by 16. 48. 48 plus 112, 160. Now notice that we have found 160 as the mixture. Now we can find the number of, we can find the mass of the pure oxide. How do you find the mass? Simple. Number of moles is equal to mass over mixture. The mass is going to equal to the number of moles we calculated to be, sorry, not these ones. The number of moles we calculated to be 0.2. Okay, this one for the oxide. So you're going to get them So we're going to say 0.02. Then we're going to multiply it with the mister, which is the 1 60. Your mass is going to be 3.2 grams. So this is going to be your mass. Now the question is saying we calculate the percentage purity. Simple. Okay? Percentage purity is going to equal to, let's check. So just go directly. There's no need to waste time because you are in the exam. Just get what you have calculated. So what you calculated is your 3.2 over what was already given in the question. The same way we are calculating in percentage yield. Okay. You even get your 80.0% as your answer. Okay. So this is how you solve this particular question. We go to this B5. B5 was actually saying, study the sketch of the periodic table shown and answer questions that follow. Note the symbols of elements given in the sketch are not the actual symbols of the elements. And then this one is saying, elements K, L, and P are all metals. Which among these is the most metallic element? Okay, so this is how it is on the periodic table. Ama metallic elements yabare both so. Ama metals yabasana metallic if you are coming from the top, mlea panji. So as you are coming from the top, you are going downward. They even become more solid, more metallic. Okay? More solid or more metallic. So this is what happens. Or if you are considering a group, you must be moving in this direction. They become so metallic. Sorry. If you are moving from right to left, so meaning ngamurefu moku mleyoku yareba metallic more. So you can use ama groups. Ngamurefu ama groups, you'll be coming from your right going towards your left. They are becoming more metallic. Ngamurefu ama period, a period, it means you will be coming from the top, mlea punch, they become more metallic. I want you to put that into your mind. Okay? I want you to put that into your mind to really be so much of help. In this case, which one is so metallic? Notice that in groups, if we are moving in this direction, it could last sano, could last, it's only K. The one which is at the far end is K. And if we are using periods, meaning we are going downward, the one which is at the lowest point is the same K. So K is actually more metallic. So we're going to say element K. Element K. Reason? Simple. It is because the metallic character increases as you go down a group. And, okay? Metallic character increases as you go down a group. Okay? Sorry, I just wanted to take some water. Metallic character increases as you go down a group or from right to left, considering a period. So if you are considering a period, you are in this direction. You are moving in this direction from right, from your right to your left. If you are considering a group, you are going downward. They become more metallic. All right, we are not giving up until we finish this particular lesson. We go to B. State one use of element S. So element S, it's here. So let's go on the periodic table. It's actually helium. So what is the use of helium? Helium is used for advertising signs or lighting. Okay. Used for advertising signs. If you go to other countries like Tokyo, you would be able to see so beautiful billboards, restaurant billboards and stuff. Okay. Or lighting. They're used for advertising signs or lighting. Even in China, even in Zambia, of course, we have on various pubs those lightings, you know, they look so nice. Okay. And it says metals have various properties and some harmful effects on humans. Explain why. Okay, it's because when these metals accumulate inside your body, they interact with your enzymes. They would be able to interact your enzymes, okay, denaturing them, or they would be able to have a negative side effect on your central nervous system. So let's say, because when they accumulate in the body, they would I would say, let me get a very good term, they would distort the function of enzymes and affect the CNS. Okay, so most enzymes would actually be affected, and enzymes are the ones that catalyze most of your reactions. So if these metals accumulate, they would distort the function of most enzymes and eventually affect your central nervous system, which you don't want. Names of metals that form part of the reactivity series are listed as follows. We've got aluminium, we've got iron, we've got gold, we've got lead, we've got sodium. Then they say arrange the metals in the increasing order of reactivity, starting with the least reactive at the top and most reactive at the bottom. So I want you to answer this question. This question is going to be your homework. I want you to answer this question. I want you to submit this question to this number 0777 66 40 46. I want to test you. I want to see if truly you understand the reactivity series. Please make sure you send the answer to this question to this particular WhatsApp number. I will need to mark you. From the list given, identify a metal whose metal hydroxide does not undergo thermal decomposition. So there's only one metal which cannot undergo thermal decomposition. Thermal decomposition simply means if you increase the degree or the temperature, either surpassing 1000 degrees Celsius, it cannot decompose. It cannot lose its shape. So how should you reason? It means that substance you're talking about should be so metallic enough. It should be so metallic enough, strong enough to resist the temperature. So from your table, of course, only sodium is so metallic. Explain why aluminium is said to be unreactive despite its position in the reactivity series. The answer I already mentioned is because aluminium readily reacts with oxygen to form an oxide layer, which prevents it from reacting with the more further oxygen. Okay? Because aluminium readily reacts with oxygen to form an oxide layer that prevents more further reaction, hence making it unreactive. This is how you answer this particular paper. So, of course, there are questions in section B that I'm going to answer, especially in the next session of my lesson. It's going to be there. Okay, you make sure that you look for that lesson, you watch it, you go through, you get the concepts, prepare for your exam, and you'll be able to get almost everything. Please, if you found this video interesting, consider subscribing right now, hitting the like button, and don't forget to share to others. Thank you so much.